Welcome, my name is Philippe Verzijp and this webcast accompanies my book Data Analysis. In it, I will show you how to transform your data into something that is usable for your purposes. If you read the book, you will see that there are many cases in which the raw data is actually not suited for the purposes we have. It will not provide us with the information we want to know. Examples are data that spans several orders of magnitude, prices when we actually want to look at changes, for example returns. We may have categories as data, and we may actually need to apply Taylor's theorem, which requires a quadratic, cubed, or even higher order transformation of the data. We'll go over these except for the dummies, which will be treated in a different webcast. Now, first of all, the logarithmic transformation. If you have data that spans several orders of magnitude, say from the tens to observations in the thousands or the 10,000s or maybe even millions, you will want to bring down that difference. Otherwise, the biggest observations are going to have a tremendous impact on your regression, while the smaller ones will have virtually no impact at all. In order to do this, we have to make a new series. We can do this by looking at the generate command. It's a button called GENR in the work file. If we press it, we can generate a new data series by entering an equation. This equation simply defines how to calculate the new data based on the old. Let's say that we take the WTI and want to take the logarithm of that. I will call this new variable WTI underscore log. Please remind, by the way, that some names, including those with spaces, are not allowed. And then I can use a function which is built in eViews, the log function. I type log, open the parentheses, and then take the name of the series I want to take the log values from. Close the parentheses. I want to do this for all my data, so I won't adjust the sample, and press OK. You'll see I get a new value, a new series in my work file. And this new series contains the values of WTI taken from which the logarithm has been taken. If I select them both, right click, open as group, I can see them next to each other, and I will see that in this case, data from the 80s, the old price was low right then, but it was $22.945. The natural logarithm of that is 3.133. It means that we take the number e, raise it to the power of 3.1331, we get that 22.945 again. This is a bit different from the 10 logarithm that you might be more used to. However, it does not affect how you estimate your equations. It only affects how you interpreted the resulting coefficients. A word of caution though with using the natural logarithm or any logarithm actually in transformations, it will not accept negative values. So if your original series contains values of 0 or below, you will see that missing values will be generated in the logarithmic transformation. Obviously this will cost you data and cause various problems along the way. Now this concludes the part regarding the logarithmic transformation. I will close this, I don't need to save this, and I will go to the next transformation. The next transformation is when I actually have, say, prices and I want to have the percentage changes, say returns. This is a situation that you will see in many applications. Growth percentages, returns, those are actually far more interesting than the underlying level number. Again, for example, we could transform the WTI series into returns. It works pretty much the same way. Again, we generate a new equation. Let's call this WTI generate underscore returns. And then I have to figure out, okay, how do I define the returns? Well, the returns or percentage changes are taken usually as follows. We take the value right now, subtract from that the value one period before, and we can do this in eViews by adding -1 within parentheses behind the actual name of the series. This difference I put between parentheses and I divide by the return in the previous period. And all of this should actually combine to give me a return, a percentage change. I press once again on OK, want to do this for the entire sample, and you'll see that I will have a new series. Let's once again compare it to the old one, and we'll see that when the oil price drops, you will actually have a negative return. When the oil price rises, which will happen a little while later, you have a positive return. Now, these are actually, if you want to have them in percentages, then you would still have to multiply this by 100, but that is obvious enough. Also, you'll see that with this particular definition, you will lose one observation. The first one is a place where the return cannot be calculated because we have no previous value to compare with. So when calculating changes, you'll always lose at least one observation. Otherwise, this is perfectly good data. This concludes the discussion about taking percentage changes. And I once again delete this, and I want to go to the last part. The last part I will discuss in this webcast is how to generate quadratic, cubed, and higher order transformations. By now you should be familiar with how to use a generate function, and I will this time use the fix as a basis, and I want to have the quadratic quadratic transformation of that fixed series. I will just give the new series, of course, a new name. Let's append SQ for squared. And I'll base it on the old one, but of course with the square transformation. This particular sign in EViews denotes that we raise a number to a certain power. And actually this is all that's to it. Once again I press OK, and we can compare the both. Now, obviously, when we take the squared value of something, we increase its magnitude by quite a bit. So you have to be careful when you have variables that indeed span different orders of magnitudes when you use a transformation like this. Also, be advised that the fix is a series which is all positive, but should it have negative values, taking the square will also make them positive. However, if we would actually take the third, raise it to the third power, take the cubed value, we would actually get a negative value once again in those places, because a negative number times a negative number times a negative number is once again negative. Okay, with these couple of pointers, we have come to the end of this webcast. Please remember that dummy variables and how to create them will be discussed in a different webcast.